So moving on to the next. So this in this slide, I wanted to summarize some of the key classes that you will come across for developing a UI. So on the left side, I have a screenshot of a typical GPS unit, and which has several components of a UI. So we have a text area, we have a static icon, we have certain animating objects like a car which goes along the screen on the road, and we have certain transparent layers. So for each of these, the corresponding Qt classes that you will be using, I have mentioned here. The graphics view and graphics scene are standard, so these are absolutely necessary for all your operations. This is the canvas on which you will be drawing on. For text, you use one of these standard classes. Static text is something that was added in Qt 4.7, which is a more optimized implementation for text items that do not change. QString and QGraphics items are for things that change often. For icons, there are various widgets which are available. We have a vector graphics widgets. We have items which can be added to the graphics view. We have QLabel, which has both button. For example, this icon has a picture and a corresponding text. So that, and you have other components also like push buttons and other components. But these are the most common. For animations, the standard class is a Q property animation. This again was added in 4.7 of Qt. In the earlier versions, there are other classes which are available, equivalent classes. For 3D, the class is visual widget, so this is not available on HawkBoard as we discussed earlier. For bitmap loading, for example, like loading this particular bitmap on the background, or for other bitmaps like this car. So there are various classes available in QPrinter and QPixmap and QImage. So these are typical classes that you would use. So you can just search for it in the Qt's web page for various operations and the APIs that it exposes. But this is a quick cheat sheet of all the classes that you can use for creating a standard UI. So we'll come back to the setting up and building Qt. So TA has provided standard instructions for building Qt for non-open embedded users as well as open embedded. So that's you can go to this web link, which is a very detailed instruction set for HawkBoard as well. And if you want a pre-built file system with Qt integrated along with the kernel image for HawkBoard, you can go to this web page. You can select HawkBoard and download a pre-built kernel and file system, which can run directly on HawkBoard with various demos already available. So these two are the options which are available for different modes of development using Qt. So for debugging and development, there are Qt provides its own integrated IDE. So you can download that off the Qt's website. So for debugging on Linux and PC, you need different component standards, native components like GDB on Linux and CDB for PC. But most now easier to just do a Q debug. This class basically prints out on the terminal, all the messages that you want to print from various places. The Antra package also provides OProfile, which is already compiled as part of the distribution to profile the application code. And you can use the Xgxperf toolkit to benchmark to your user interface components running at specific frames per second. So we'll quickly go on to the Qt Creator. This is how it looks like. I hope you can see it on the screen properly. So there are various components like the Qt Designer was renamed to be Qt Creator in the latest version, but this is a standard way by which you can create. So there are various components which are available on your input window. You can choose one of them and create a new form. For example, this is your UI form. So here what I have done is I have taken slider from here and several different LCD numbers. For example, this is the LCD number what I have here. I have taken that from here. You can just drag and drop from here into the form window and create a form, and you can save it as a .ui file. When you save it, it goes and saves as a .ui file. And you can use that .ui file and you can pull that into your application directly by Qt classes. There are classes which are available specifically for that. Again, so there are specific examples in Xgxperf which show you how to do that. So you can take a look at that. But this is a very good way of creating a standard user interface without doing it manually. You can choose the layout size, for example, the screen size that you want, and you can position the static text. You can create various widgets directly on the screen and use it for a nice looking window. Created a .ui file. So from your in your Qt project, so you can define you can use this mechanism. I will not spend a lot of time on this. It's a standard Qt call, so there's a standard example also provided in Xgxperf. So you can use this call called setup UI with the UI main window class. So you can directly use that to set up your UI. So once you do this, all the components that you created in the earlier window, for example, this is component 1, this is component 2, this is component 3. So all these widgets are available for use by the application. So you can modify those components in code programmatically and update them dynamically at runtime. So this is how you use you merge the statically created .ui file into your dynamic runtime application. Again, just to summarize, so this particular example in Xgxperf contains an working example of how to use the .ui file and how to import them into your application. Okay, so this is how you import the .ui file. So this is a standard example. So in the interest of time, I'll move forward. So coming to Xgxperf, which is a toolkit. So what is Xgxperf? It's a collection of ready-made examples and classes for different end use cases. So we have ready-made examples for industrial automation HMIs. We have medical use cases, ECG monitors. There's the automotive display, simple automotive tachometer display. There is a surveillance use case. So all these are pre-built and available to the user. So it uses graphics view. It is configurable for various input parameters. There are other additional useful classes that are provided. So LiveMem is a class which is a display plugin. It can use it as the off-screen display plugin for Qt embedded. So all the rendering operations for Qt are stored in a off-screen file, so which you can later see how it looks like. So, for example, if you don't have a display connected, you can you can still use your HawkBoard for analysis without connecting even a monitor. So there are other useful classes, and there is application note readily available right now. You can read through that to create your own application, and this is a wiki page. So I have summarized here how to use this Xgxperf. So you can check out the source code from here, and both for non-OE users as well as for open-embedded users, I have specified here. So there is for non-OE users, there is a simple root.make file that you need to update and then do a make and make install. For OE users, you need to use this recipes which are provided in this package. So you can use that to create your own package and directly install it onto your target using these steps. So just to summarize again, so these are the pre-configured applications which are available in this slide. So we have industrial automation sample, we have a widget plus text sample, we have a simple medical use case, we have automotive tachometer, we have a video surveillance use case, and we have a simple picture of a standard swing machine use case. So there are various standard tests which are available that you can run, and so these are the configurable parameters for invoking Xgxperf. What are the type of elements? What are the size of the components? What is the target frames per second that you want to update the UI, and what are the various configurations of text and pictures, and various other parameters relating to 3D as well, which may not be useful for HawkBoard. So once you run this, after the run is complete for the specified number of runs, it creates a HTML file with the profile information as to how much was the UI took to create. So these outputs will be useful for when an application is started, when you are creating a new application, so that you can use it to benchmark which class is taking more time, so that you can optimize your application right from the start. Okay, so I'll show you a summary of how we can do new application development using Xgxperf. So again, there are various methods to use Qt development, but this is the mechanism which I thought would be beneficial because we have predefined classes which are available.